Hi everyone, welcome to my channel EDU Tech. Today we are looking for diffusion capacitance. Okay, so there are basically two types of diode capacitance. One of the transition capacitance and diffusion capacitance. In this video, we are looking for diffusion capacitance. So how it is going to perform diffusion capacitance? Let's see in detail. So diffusion capacitance. Now what is diffusion? Diffusion is nothing but movement of charge carriers or recombination of charge carriers. Okay, let me explain clearly. So this is P type and N type, which is connecting as electrical connecting ohmic contacts. Because of this ohmic contacts only between P type and N type electrically passing. Okay, then which is connecting to the terminal DC terminal of the both types. P is connected to the positive terminal, N type is connected to the negative terminal. Okay, now what will happen in this case? When voltage is applied, then increasing the voltage, then these holes are moving from P type to N type, and electrons are moving from N type to P type. So obviously, what about this width? This width is nothing but depletion layer, that is represented W width. So when increasing this applied voltage, the holes are moving and electrons are moving across the junction, then width becomes decreases, that is depletion layer becomes decreases. So what will happen? Current will flow. Okay, so this depletion layer becomes narrow. Whenever applied forward voltage, the depletion layer becomes narrow, then current will flow very freely. That is the concept about this diffusion capacitance. But here why it is added as capacitance? Because this is acts as a capacitive effect. It is considerable as a capacitive effect. That is what like this. This is diode and which is connecting like this. So diode acts as a capacitive effect. Okay, now let's find out in that what is the moment of charge carriers. Here CD equal to, what is CD here? Rate of change of charge at junction divided by rate of change of applied voltage. Rate of change of applied voltage. So what is the meaning of it? So when applying here voltage and holes are moving and electrons are moving across the junction, because of this flow of charge carriers with respect to change in voltage. Okay, change in charge with respect to change in voltage. That is what given by CD. So CD can be written as dq by dv. Okay, hope you understand. So CD equal to change in charge by change in voltage. Because of applied voltage, here changing the width. Okay, depletion layer becomes decreases, current will flow. Okay, that is what given CD, diffusion capacitance. And now what is dq, that we have to find out, right? So now when you are applying forward bias, current will be existing. So because of change in charge with respect to change in voltage, in that case the flow of charge, the flow of charge carriers, the flow of charge carriers q results in diode current, results in diode current is given by I equal to q by tau, where q is nothing but charge, where tau is nothing but recombination lifetime. Okay, so what is recombination lifetime means? Movement of holes are moving here, electrons are moving here, so across the junction. So that is what recombination takes place, that is what tau. Now this can witness, this is equation 2 I have considered, and this equation can witness q equal to I into tau. This is equation 3. Okay, now q equal to I into tau. Now for the simplification I am considering from the diode current equation, as you know, I equal to I naught into e power v by eta vt minus 1. So this is the expression for diode current equation. Now this equation substitute in place of I. So q equal to, in place of I, that is I naught into e power v by eta vt minus 1. Okay, into tau. Okay, now this tau and I naught multiply with in this term. What will happen now? So q equal to I naught into e power v by eta vt minus 1 into tau. Now you should multiply I naught into tau in this expression. What will get it? I naught into tau into e power v by eta vt minus I naught into tau. This is the expression getting. Now from this expression I am going to differentiate with respect to v. We get, so dq by dv, that equal to d by dv into I naught tau into e power v by eta vt minus 1, that is minus d by, so I into I naught into tau. Okay, I am taking whole bracket. Now this can written as d by dv into I naught into tau e power v by eta vt, then d by dv into I into I naught into tau. Now differentiation with respect to what? V na. So in that case this I naught tau is a constant, so that I am taking out, and d by dv into e power v by eta vt minus d by dv into I naught into tau. So this can written as, so I naught into tau, differentiation with respect to v in the sense that is e power v by eta vt into v is there now, that is differentiation v means 1 by what is constant, you will get eta vt minus this term is totally constant, that becomes what? Differentiation with respect to constant, that is 0. Okay, now what is the equation becomes? I naught into tau e power v by eta vt into 1 by eta vt, that is dq by dv. Okay, now this can written as, get into here, I naught tau divided by eta vt into e power v by eta vt. This is dq by dv. Let us consider equation 3. So before that we consider as what? Equation 3. Let us consider equation 4. Okay, now from this above equation, let me write as that is tau divided by eta vt into I naught into e power v by eta vt. So by simplifying this expression, again you may take from the diode current equation. We get I equal to what? I naught into e power v by eta vt minus 1. Okay, now this I naught multiply this expression. What is equation becomes? I naught into e power v by eta vt minus I naught. Okay, now this I naught get into the LHS. That becomes I plus I naught equal to I naught, that is I naught into e power v by eta vt. Okay, so now this is equation 5 and this is equation 6, right? Now what you do? From this substitute equation 6 in equation 5. We get what is the expression becomes? C. This is the equation 5. So dq by dv that equal to this is tau divided by eta vt into, in place of I naught into e power v by eta vt is nothing but what? This is I plus I naught. Okay, in that dq by dv equal to tau by eta vt into I plus I naught we considered. Now in this case I is much greater than I naught because this is reverse saturation current. This is reverse saturation current and this is forward current. So this is in terms of milliamps and this is in terms of microamps. So under forward bias condition this is high current, so this is negligible. Okay, I naught should be negligible, so that equation becomes dq by dv equal to tau divided by eta vt into I. Okay, now dq by dv equal to I into tau by eta vt. Now this dq by dv is nothing but what? Cd equal to dq by dv that equal to I into tau by eta vt. So finally this can be written as Cd equal to I into tau by eta vt. This is the diffusion capacitance of the expression of Cd. Okay, so thank you for watching my video.